Welcome, everyone. Thank you for joining us today for our live web stream of the PyTorch documentary. This webinar comes on the back of a highly successful premiere of the documentary last week in Paris, France, where we had over 100 attendees from the PyTorch community in attendance. We had a red carpet event with members from the PyTorch community, including the core maintainers and contributors, along with the PyTorch founding team. The event was a resounding success. So the motivation for the development of this documentary, which began last year, was to pay tribute to all of those in the PyTorch community who have invested countless hours to create not only the best deep learning framework available, but who have also contributed to the growing PyTorch ecosystem, which now includes well over 100 different tools and libraries, including diffusers, transformers, Ray, and PyTorch Lightning, making PyTorch the go-to framework for researchers and developers. Today, we have special guests from the documentary sponsors from Meta, Microsoft, AMD, and AWS, who all helped contribute to the success of this documentary and last week's event. I have the pleasure today of being joined by Sumit Chintala from Meta, Paranita Rahi from Microsoft, Niles Burbank from AMD, and Brian Granger from AWS. We will start today's event with questions for our special guests, and then we will move to the live stream of the PyTorch documentary, followed by audience questions. With that said, let's get started with our first guest, PyTorch's co-founder and core maintainer, Sumit Chintala. Sumit, could you please give our audience a brief history of PyTorch and why the development of this documentary was such an important milestone in the evolution of PyTorch?
Sure. Hey everyone. I think the PyTorch itself, we started PyTorch just as a tool to build our own research and express our own ideas, and then we grow it among a bunch of researchers that we knew, and it slowly and organically started growing. And at some point, we realized PyTorch is powering a lot more of AI than we've ever imagined across a bunch of products that we even use day to day. I think after it crossed that threshold where PyTorch started being in your Tesla car and your pet care, we kind of rethought how we should think about and care about PyTorch, and started seeing it becoming like an instrumental tool. And so I think the documentary is to recognize the humble origins, but also document the journey of how it started integrating into AI across various applications that we've never imagined.
Great. Well, thank you, Sumit. I'd now like to ask Paranita about Microsoft's role in PyTorch and fundamentally why PyTorch is so important to Microsoft and its AI framework strategy.
Hey, Matt. Hello, everyone. Yeah, great question. I think Microsoft has been part of the PyTorch journey from quite the beginning. We have been committed to democratizing AI and working together to make sure that AI is accessible to developers across the board, irrespective of level of experience and ability to understand very complex coding. And in that aspect, I think PyTorch has been super instrumental as we have seen the growth of AI in Microsoft across its suite of products, be it the Copilot, be it the Azure OpenAI Studio, be it a bunch of AI models that powers a lot of our services. PyTorch has been a key enabler for that. And we have consciously kind of worked towards making sure that we are making it easy, making it optimized to run PyTorch through our development cycles. be it for fine-tuning models, deploying models, developing new models, and coming up with new scenarios that can empower all the different Microsoft capabilities. And we are very happy to be a great partner, and will continue to do so.
Excellent. Thank you, Purnia. Now, so I'd like to ask you about the role of AMD and PyTorch, and how PyTorch and ROCm can be leveraged by the community for deep learning applications.
Yeah, certainly. Thanks for the question, Matt. So AMD has a big portfolio of products that are potentially useful for AI and ML, but really the starting point for us with PyTorch was our GPU portfolio. And if I could digress for a second, the graphics and GPU area is one where I've worked for several decades, and with the advent of ML, I've never seen as much general interest from my acquaintances outside the core technology community as we're seeing now through machine learning and through technologies like PyTorch. But back to the question, we're always looking at making our technologies as useful as possible to our customer base. And PyTorch is clearly a tool that allows a range of users, from users who either don't have the need or the desire to learn about the inner workings of the technology, just want to produce results, through to users who do want to very deeply adapt all the capabilities of PyTorch to their use case. And the GPUs that AMD produces are great tools to make PyTorch more powerful. I'll say that one thing philosophically that we're very well aligned with PyTorch on is our embrace of open source. Our ROCm software stack, which was part of your question, is an open source compute software stack. So it's very much aligned with the philosophy of PyTorch generally.
Oh, that's great. Thanks. And so next, I'd like to ask Brian from AWS about what you love most about the PyTorch community, and how is AWS involved?
Yeah, hi everyone. Thanks so much, Matt. It's great to be here today. AWS is really proud to participate in this collaborative and vibrant open source community. I think a key characteristic or attribute of the PyTorch community is its focus on users and understanding what users need, and relentlessly working to bring that to them. And I think scaling an open source project to this level of activity and contribution while maintaining quality and developing an ambitious roadmap can be really challenging. And I think PyTorch 2 in 2023 was a great example of the ongoing success of the PyTorch maintainers and contributors in managing the project. Personally, I love that PyTorch has a multi-stakeholder governance model, and really moving to the PyTorch Foundation has solidified that and allowed that model to grow. And at the same time, PyTorch has been able to sustain growth and remain innovative. And oh, excuse me, sorry. The best open source projects are about more than just software and code, but also about the people and community as well. And maintaining that dual focus between community and code is a real challenge for open source projects as they grow and mature. And I believe that PyTorch is striking that balance well, and as a result is bringing value and innovation to a large number of individuals and organizations. In terms of how AWS is involved, we first got involved a few years ago when we worked with Meta to create TorchServe, and we continue to contribute to TorchServe. We've also been helping the PyTorch Foundation set up the CI and testing infrastructure as things have moved over to the PyTorch Foundation. And then for AWS customers, we have many different teams working to make AWS a great place to run PyTorch for both training and inference. So Amazon SageMaker has PyTorch integrated deeply throughout its training and inference experience. We also have custom silicon with AWS Trainium and Inferentia EC2 instances, and the AWS Neuron SDK has built-in support for PyTorch for running on this custom silicon. And again, for us, it does all go back to what users and AWS customers need. And we're thrilled to participate in this community and excited to see the growth and excitement around PyTorch right now that is captured in this documentary. And so really a privilege to be here today. Thank you.
Great. Thank you very much, Brian. I really appreciate what you said about the importance of open source and the role that plays in democratizing access to deep learning. So I'd like to thank all of our speakers today for volunteering their time for today's event, as well as the production of the documentary. And of course, we will have them back to answer questions from the community. So without further ado, I'd like to present the PyTorch documentary. Please enjoy, please stick around and pose your questions to our guests after the premiere here. Thank you.
These are fun questions. Obviously, we're in the middle of an explosion in the whole AI space.
The state of AI today would be very much less developed if PyTorch hadn't have come out.
You wouldn't really have ChatGPT today, you wouldn't have Stable Diffusion.
If we roll back in time, if we don't know all this, at the time we made this decision, we are not 100% sure.
AI was a kind of a black box in some sense that people have to know how to write a program and compile it and then run it. And so it was not easy for researchers of many interdisciplinary domains.
There was quite a lot of variety back then, so there was a lot of focus on experimentation.
A lot of innovation was happening, but it was pocketed, like, the big players were doing individual model development, and a lot of it was siloed within, individual organizations or research institutions.
There were like 15 or 20 tools that at that time were all trying to enable research. Lots of directions for AI research.
The software ecosystem was fragmented, incredibly fragmented. You had Torch, of course, with Lua. You had Theano out of Montreal. You had Cafea coming out of UC Berkeley.
They crossed the bar between being a cute tool and being actually useful. People started wondering if there are very nice tools to run these kind of methods, and as well as having more new algorithms coming out.
Circa 2015, there were a number of different frameworks. And the challenge we had at the time was taking this significant number of frameworks and providing the support for all those. We could hear from our customers clearly that the machine learning was an area of, even back then, a significant interest. The challenge was how to actually deliver support for that in a focused way.
It was exciting because it was both chaotic and it was high budget. It was that moment where it's like, we still haven't converged yet, and there's like money everywhere, there's resources everywhere. I think one word to put it is chaos. Facebook started a fundamental AI research lab. It was called Facebook AI Research, and after Facebook changed their name to Meta, it became Fundamental AI Research Lab.
There was a unique opportunity in creating an organization which would have a very ambitious long-term scientific goals, but at the same time would have a big impact in the world.
FAIR was trying to make progress in computer vision, which is if you want a computer to understand everything as you see things. If you say, this is a table, this is a chair, this is a dog, this is someone's feeling, you want the computer to be able to grasp all of those semantic things as well.
Facebook then is also going through a transition on mobile first, right? It was a desktop first application, and a lot of AI features at the early stage need to happen on mobile, and how to fit into those AI features on mobile is a big problem. And that's where Cafe2 got started, and its starting point was laser focused on making those AI features work on mobile phone natively.
It was actually shipped across Facebook's fleet and on newsfeed, ads, search, and things like that, as well as computer vision, natural language processing. It also got shipped onto the phones. We had a cute name called Cafe to Go that allowed it to be shipped on something like 1 billion phones.
Even though it wasn't quite the best framework for research or exploring new ideas, it really became kind of this project that everyone started using and really even started using it at scale.
We have world-class researchers, they are pushing the boundaries, so they need the best of the tools, and there's a huge gap.
In 2015, I was leading the Lua Torch team, and at that time, I was helping people both at FAIR and outside within the industry. DeepMind, Twitter, Facebook, and a bunch of other academic and industrial labs were using Lua Torch.
And if you look, though, at the developer experience or really the tools that were available, I mean, none of them were very good. It was, I think probably the best experience was probably Torch, but no one really liked to use Lua. It just didn't have an experience, like an ecosystem or community around it.
Being outgrown, AI researchers outgrowing Lua Torch. So someone needs to go build a new tool. In 2015, December, TensorFlow came out. It was from Google, high budget, high marketing, like all the way up to the CEO. They just took over the world with the news. One of the things that was distinctive between TensorFlow and all these other tools was all these other tools were started by enthusiasts, by researchers as a way for them to do their work. Whereas TensorFlow was built from the ground up with Google engineering. People realized TensorFlow had a certain credibility and a certain polish that all these other tools either needed to catch up with or they would just lose out. Facebook felt that they needed AI to make faster progress for Facebook itself to scale better.
Facebook saw a huge need in AI applications, both on the cloud side for search, advertisement, news feed, and also for basically recommending people interested in multimedia contents, interested in cats and things like that. So the need for a high-performant product-ready framework was actually one of the biggest needs. And I think that was about the time when I joined Facebook. And one of the very first tasks was to basically build a framework that will be battle-tested for hundreds of trillions of predictions per day and all kinds of different deployment environments.
So in 2016, May, one of the Lua Torch community members, Adam Pashka, he was a first-year undergrad at that time at University of Warsaw. He messaged me and he said, hey, I know it's a little late in the intern cycle, but I couldn't find an internship anywhere. Do you have any openings? And I said, yeah, I do. Why don't you just come and build a next version of Torch?
I was kind of excited about machine learning. I just thought it was a really cool field and I wanted to learn more about it. I was looking around and I saw Torch 7. People were excited. One of the big industry labs was using it, FAIR in this case. I used it to learn machine learning, but I guess over time I kind of naturally just realized that actually I ended up being more interested in kind of building the library itself more than actually using it.
So from 2015 December through 2016, April, we separated the back end of PyTorch, which is all the software that runs scientific computing code on GPUs and CPUs, from the front end on how you express your ideas. We hadn't even thought through what we want to do about it, but we at least were like, well, let's just clean up the back end.
We essentially started taking the sort of implementation of the math functions that were all like in lower level languages like C, C++, and just separated them from the bindings that expose them to Lua, right? Which were essentially half of Torch 7. And by the time the separation was complete, by the time we had those libraries that could be essentially linked to any other language, then it was a question of which language besides Lua we choose. And so since it was a pretty natural question, all the other libraries were already in Python, and people were happy with it and they were liking it. So we were like, it's kind of a fairly natural next step just to try to take what we have now that it doesn't only work in Lua and just try to bind it into Python. And so I just started reading C Python documentation. They actually have really good documentation for how you, expose new types, how do you expose C functions and stuff like that. And so I just, slowly started building out the prototype just from the ground up over there.
And so in 2017, January, we released it. And I think one thing we're saying is we knew we were like a small effort, tried to stay very focused on the market we knew well. We said, we'll just go for AI researchers. That's who we know well, that's who we serve well, and we'll take it from there. We'll see where this goes. What made it worth it was several people giving us feedback that we are enabling them to do great work.
My wife and I started Fast.ai with the view that we wanted to teach people that don't have a PhD how to take advantage of neural networks and deep learning. So we were thinking okay, can we create a introductory deep learning course? And then I hit a wall. I was trying to implement recurrent neural networks, which is the foundation at the time of natural language processing. I had an algorithm I was trying to implement, and I wasn't smart enough to do it. I couldn't do it. I couldn't get it working. And it was unbelievable timing, because literally that week, I have a week to prepare the course. I'm 2 days in, I'm stuck, and an announcement appears of a new library called PyTorch. The key thing about PyTorch is that it really leveraged and engaged with and highlighted the Python programming language. You write a line of normal Python code and it runs it straight away and it gives you the result. It just all made sense. And so literally I learnt PyTorch, implemented a new research idea, wrote the lesson about it in the 5 days that I had left. It was really transformative for me.
What we were doing at the time was we had these monkeys, and when the monkey passed away, a lab at Stanford would cut out the retina, put an electrode, and then we would show net images to it. And so the neurons in the retina respond to the signals. And so you end up getting a bunch of spikes, basically, right? So you get zeros and ones when the neuron sees light or it doesn't see it. So we were doing actually decoding. So we had the signals, just a bunch of ones and zeros that came from neurons, and then could we figure out what image it was based on that? So we use something called GANs, generative autoencoders, which is now, I think, the OG Gen AI, right? Because it's you gave it a bunch of inputs and then it gives you an image, right? Now, the images back then were super blurry, not like today's images. And so we were using deep learning to do that. So when I was trying these different ideas, TensorFlow came out, and I switched everything and then rewrote everything in TensorFlow because I wanted to run on multiple GPUs.
TensorFlow was we want you to write code like this, and Python doesn't really look like that. So we will smash at Python until it kind of fits our view of how you're meant to write neural networks. Whereas what Sumit and Adam did with PyTorch was they said okay, here's Python. How can we really use that language and to connect it to what deep learning needs? And it was really delightful.
PyTorch came out. And then I was like, oh, this makes a lot more sense. For a researcher, it was just easier to look at the code and like map it to the math. And like I could read it in like 7 lines of code. I could see what we were doing in 50 other lines of code. So it was like night and day. So it took a few days and then we were on the PyTorch train after that.
The first few months after we launched, we really amplified the community. That's mainly what we did.
So if users found that there was an issue, we would turn around a PR to fix it within hours. And just that fast cycle time, it earns trust with the users.
There was Piotr Bilecki. He was a researcher in Germany, and he started jumping into the forums, answering questions alongside us. I think he has, at this point, some ridiculous number. He answered like 10,000, 20,000 questions on the forum. People are like, oh, you're doing AI research, then obviously you ran into this person, which is like his profile picture. In 2017, I think we were working 16 plus hour days, saying we were just happy we were getting to do it. End of 2017, a new VP of AI came in to Facebook. And that person was Jerome Pezzenti, and he looked at the problem and he saw a clear problem just internally at Facebook. He said, look, my research team is doing great, my production team is doing great, but there's not a lot of transfer that's happening between research and production, and why is that?
The situation was we had a great system running for the product side, Caffe 2, and we had a great system running for the researchers, the early version of PyTorch. Now, the challenge is that there isn't a way for us to move between these two worlds as easy as possible. So we were like, well, how do we actually solve that problem? The very first thing we did was to build an intermediate language that would allow us to ship models from one to another more easily. And we had an internal project called the Toffee IR. Toffee is basically this torch and this cafe, right? That ran for a while, and at some point we were like, it was pretty useful. So we're going to be open sourcing it and driving it together with the industry. So Microsoft, AWS, NVIDIA, and a bunch of other partners basically grouped together and then renamed the project Onyx, Open Neural Network Exchange, and we open sourced it as one common standard.
By like mid 2018, it was pretty evident within the industry that there's only 2 frameworks who are going to capture most of the market, and there's a rapid consolidation happening. That led to us being like, well, if there's only 2 frameworks, why do Onyx at all? So instead, what we did at Facebook was we just decided to merge PyTorch and Caffe 2 to do both research and production well.
And so we started the PyTorch 1.0 effort, basically trying to combine the front end, the intermediate abstractions, and the back end together so that we have one unified technical stack to run this thing end to end.
We call the zipper approach. The idea here is let's take the also front end of PyTorch is super easy to use, and the high performance back end of Caffe 2, and zip them together. It should just work beautifully. But we tried for a couple months, and then we realized, oh shit, the API completely doesn't align with each other. They were never designed to interoperate with each other. And then we took a different approach. We 100% focus on PyTorch, just say, we keep PyTorch code base, and we just make it highly performant for production. We don't know if it's going to work at that time, but we're going to try.
PyTorch and Caffe 2, the merger was about cultures coming together, understanding each other, respecting each other.
Imagine if there are like a research team who favors flexibility and a product team who favors performance coming in together. It's really difficult to figure out what we actually want to achieve. It was a chaotic moment, I have to say.
That took us, I think, a good 2 years to work with the product team to evolve PyTorch into full productionization for personalization.
The resulting product, we called it PyTorch 1.0.
I think, when PyTorch 1.0 came out and we started to see libraries explode on top of PyTorch. It was libraries for NLP, computer vision, reinforcement learning. The whole world started to build on top of it as this kind of stable foundation.
And one of the things we started seeing after that was really cool, almost intimidating to us as a PyTorch team, is a bunch of self-driving car companies, including Tesla and Cruise and Uber, started using PyTorch for the self-driving.
I was actually at Uber. We were working on self-driving cars. This was in about 2017 timeframe. And I was responsible for building ML platforms at Uber. And we had multiple research teams building self-driving car models. And the first time when I heard about PyTorch was one of these research folks wanted to try this new framework and see how fast it can go. And what was very interesting was that the speed in which, in terms of the iteration speed, we saw from that team significantly was more than the other teams. So we could actually move faster just with iteration speed. And that's when I heard about PyTorch for the first time. And I started actually dabbling after that.
To me, that was one of my favorite use cases, just because of the impact is so easy to grasp. I think there's nothing more real than when you sit back in the backseat of an autonomous car and it's driving you around. And you're like, wow, that's the tools that I worked on and the community that I helped to build are actually powering this car as I'm driving. That kind of brought it home for me.
It is both extremely cool, extremely intimidating, and makes us feel very responsible for the code we write and making sure we don't have bugs in them.
But the interest, just the excitement from the community was through the roof.
The only thing we tried to make sure of is we took signal from a diverse enough crowd so that one single segment of people didn't just define what PyTorch would be.
AMD, at least at that time, we were not ourselves significant users of machine learning. So what we were doing was responding to what our customers were telling us that they needed to do their work. At around the time that PyTorch was introduced, it started coming up in conversation, not as the preferred framework initially, but a lot of customers were saying that this was something interesting that they were looking at. And pretty quickly after that, it moved from this was something interesting to this is something we're using and we like, to in a lot of cases, this is now our preferred machine learning framework. So it was clear based on us hearing that from a number of different customers of different sizes across different industries that this was something that was going to be important.
The software tool needs to work really closely with the hardware it is running on and optimize itself further on that hardware.
AMD could see that this was going to be an important project, and we started working on taking PyTorch and adapting it in a way that it could take advantage of the hardware acceleration capabilities of particularly our GPU products. We did that initially by just taking a fork of the PyTorch project and making our own changes and proving them out to ourselves. The next step after that was contributing those changes back into the master PyTorch project so that they would be available to the wider community. Over the course of several years, we, working with the PyTorch community, established ourselves as a robust, reliable solution that wasn't going to put a black eye on PyTorch, that was going to be additive to the PyTorch value proposition.
Even Google on their TPUs, which was kind of their holy grail or their crown jewels of their hardware, they said, well, we actually should start thinking about supporting PyTorch because we're seeing so much demand for it.
Google were building TPUs, and they've been having TPUs since 2014, 15. And Google seen customers wanting to run PyTorch workloads. There was this giant project across Google, Salesforce, and Meta in terms of how do we enable TPUs for PyTorch. but also proved a point that you could take PyTorch from research to production and onto not just GPUs, which was kind of like the focus before, but also to other hardwares like TPUs. And that was a pretty big moment.
And so I think what that helped really is started to really provide the community options and really a way for them to run on different types of platforms. And so the goal, I think, is really to bring PyTorch into every place possible, whether that's on the edge or the mobile device or in the cloud. Really want to just make it really accessible for developers, whether they're training small models or large models, or they're trying to deploy in their applications. They need hardware support, and that's where our hardware community really jumped in and really made that possible.
If you want to run a large AI experiment, you have to run it on, say, 100 GPUs or 1,000 GPUs. So you want it to run somewhere where someone knows how to deal with that much power and heat. So cloud providers obviously have played an important role in accelerating overall computing.
As PyTorch was growing and picking momentum, a lot of internal Microsoft teams had developers and models that were using or have started using PyTorch, so that was growing. What it didn't have at that time was an infrastructure. That led us to see the potential of enabling PyTorch with Azure and making PyTorch a first-class citizen on Azure so that more and more innovation can happen, not just within Microsoft, but even customers and developers and enterprise that uses Azure.
The engagement of AWS with Meta and PyTorch happened in the first year I was at AWS. So this is 2018, 2019. A key part of the AI ML strategy for AWS is helping as many people as possible access that for their work. At the time, PyTorch was not as performant or production ready as some of the other ML frameworks. What was notable for us, though, is that we saw researchers starting to adopt PyTorch, and we viewed that as an early leading indicator of future customer adoption.
Microsoft uses PyTorch for a lot of services and applications across the board, be it Bing, cognitive services, Office, the ML models running behind it. It's all built with PyTorch. It only makes sense for Microsoft to make sure that the experience and development of PyTorch grows.
Our cloud partners were instrumental in scaling PyTorch for sure. They've acted as a distribution channel. They've acted as a contributor to the project. They've been an enabler of hardware and platforms. They've been a promoter and go-to-market. Really, everything around the ecosystem, they've helped, kind of elevate and accelerate, I would say.
Startups are required to have a laser focus on their core value. And most of the startups leveraging AI, their core value is not in purchasing servers, installing the servers, configuring the servers, maintaining the server. It's 100% distraction. And so the cloud providers, I think, have played a critical role in enabling those startups to be laser focused on the actual problem they wanted to solve for their customers.
At that point in time, we had big partners kind of go all in. And probably one of the most notable partners that we had go all in was OpenAI. And they were a big PyTorch user and a big PyTorch contributor.
The landmark moment in the world knowing something called generative AI was, one is GPT-3, eventually became ChatGPT, and the other is Stable Diffusion.
Whatever you hear these days, right, like be it OpenAI models, GPT, all the fancy AI innovations that you hear about, at the back of it, PyTorch is driving it.
The only way that that's been able to happen at this pace is by some degree of openness. right? And this is both on the open source software side, that you need tools that are open source, that you can build something, and then someone else who's not directly working with you can continue with it. And to do that, you need tools like PyTorch.
And frankly, I don't think we would have the explosion we had without, some of the things we had done. All the tools that, for example, the Stable Diffusion team uses PyTorch Lightning, which is a community project that was built on PyTorch, not by our team, but by the community. And so when you start to create that kind of innovation, and it creates other projects, and it then creates tools and things that allows people to innovate in the way that, for example, Stability has or OpenAI has. You look back and you're like, wow, I can't believe this happened. And I can't believe it happened on something we built.
While great innovation was happening, we do want to make sure that we remain committed to making sure that PyTorch is not just a mechanism or framework that's driven by a handful of folks.
So the goal was to more like build this platform, and there were a lot of other companies built on top of PyTorch and have incentives to make PyTorch better. We want to kind of enable and kind of democratize or make that even bigger.
My background is in multi-stakeholder, community-governed open source. Meta was, from the start, really focused on building that community and making it an open and welcoming place for everyone to come and contribute.
We saw that if we moved PyTorch into a truly community-governed project, it would grow even bigger and keep itself more robust and not fall to the pathologies of one single entity.
For long-term sustainability, anyone who creates an open source project eventually is going to have to give up that control.
We really got it set up in 2022. Our founding members were NVIDIA, AMD, Microsoft, Amazon, and of course Meta on the board. They're really chosen, I think, for I would say the prior contributions that they made.
I think the creation of the PyTorch Foundation really is a culmination of Meta's direction on this, and it's gone really well. It is a vibrant group and also a growing group. And there's a lot of interesting work that's happening right now in the PyTorch Foundation to help this grow and to be a sustainable and long-term open source project.
PyTorch is trying to make sure it keeps up with all the needs of the AI industry. PyTorch stands for pragmatism, and it will try to make sure it evolves as fast as the AI industry needs it to evolve.
And now we are running more than 5 trillion inference per day across 50 data centers. So I believe that number keeps going up.
Like every day we look around and say, like, yeah, that's us in there, that's us in there. It was so much fun to see.
I still think we are still like getting started, and with the future things on kind of post on the on-device side, that's going to go. But in addition to that, the newer ML experiences, LLMs, how are we going to fine-tune things faster, but also kind of being more long-lasting as well.
I think we all see the world is in the future much more diverse, whether it's on-device or kind of ambient computing or wearable. So I think like PyTorch will be that kind of center of mass to bring the community together.
What we'll see going forward is more and more applications that are built using these powerful LLMs that are made available. The sky is the limit in terms of where people can have an idea and they are not limited by technology or hardware, and they can apply their idea to build solutions that make their life more enriching, productive.
When you apply more hardware or more iterations to the problem, the same basic techniques continue to yield better and better results. There's an almost insatiable demand for more and more compute capacity as researchers and industrial customers take these particularly large language models, as we're talking today, and scale them up in ways that even by the standards of the computing industry are sort of unprecedented.
The real value of foundational open source projects is a long-term value. Foundational open source projects, whether it's Linux or NumPy or Jupyter or PyTorch, the deeper innovation happens over multi-decade long periods. And what happens over those longer timelines is that other people build layers on top of those open source projects. And as individuals and organizations adopt the open source projects, they're able to do things that they could never do without those layers of innovation on top of those open source projects.
My personal feeling is that AI is going to be growing much larger and larger than frameworks. And then PyTorch is going to be one integral part of it. People are going to be spending less and less time worrying about it, but people are going to be more and more dependent on it because it has become a standard piece in the software stack.
And then I think the next breakthrough will certainly be on PyTorch. I think, we had GPT-3, we've had GPT-4, we've had diffusion models. That next breakthrough is going to be on PyTorch.
Well, I kind of felt proud that PyTorch is one integral part of this whole journey to fuel all those innovations and large-scale applications.
So the AI industry, at some point, like all industries, will cap out. Until then, it is on a fast-moving curve. But as of now, PyTorch is a fairly general tool where you can express fairly powerful mathematical ideas, and that is important for the AI industry.
Welcome back, everyone. For those who did not join us during our Q&A session, I'm Matt White, the Executive Director of the PyTorch Foundation and GM of AI at the Linux Foundation. And I'm joined by Sumith Chintala from Meta, Niles Burbank from AMD, and Brian Granger from AWS. So undoubtedly, PyTorch has played an integral role in the success of deep learning research, which has brought us to where we are today, with PyTorch powering most of the contemporary generative AI models, along with conventional discriminative models. The PyTorch framework's flexible and user-friendly architecture has not only accelerated the pace of innovation in AI, but also democratized access to cutting-edge tools across academia, industry, and especially due to its open source nature and the neutral governance of the PyTorch Foundation. And furthermore, PyTorch's extensive ecosystem of libraries and tools, along with its strong community support, continues to push the boundaries of what's possible in AI, making it an indispensable resource for researchers and developers looking to craft the next generation of intelligent systems. We do hope that you enjoyed the documentary. You will be able to find it on the PyTorch YouTube channel after today's event, and please do share with colleagues and friends. So now we'll move to take questions from the audience. So I've got a question here from Daniel Johnson. How did the previous Torch library for Lua influence PyTorch? This is for Sumit.
Yeah, I already answered that on comments. But basically, the previous Lua Torch library was what the PyTorch community used before writing PyTorch. So it's pretty central to influencing PyTorch itself. And also the initial CPU and GPU backends were shared between Lua Torch and PyTorch projects. So that's like another angle of influence.
Okay, I've got a question here for Niles. what do you think is next for PyTorch from AMD's perspective?
Yeah, well, AMD has GPUs most famously in the context of machine learning and PyTorch, but there's a lot of other hardware in our portfolio as well. And over time, I think we want to expose all of the accelerators that AMD produces through PyTorch.
Okay, great. All right, we've got a question here for Brian. So how do you see PyTorch and cloud infrastructure, including edge infrastructure, scaling together?
So there's a lot to train these large models, in particular multimodal models. There's a lot of things you have to get right. Obviously, you need PyTorch, but then you need a lot of things around that. And so one example is when you're training at scale, hardware reliability becomes a major limitation. You know, when you're training on very large GPU clusters with thousands of nodes, you're going to have failures of nodes. And so being resilient to those types of failures requires obviously work on the PyTorch side, but also work at the lower level infrastructure. And this is something that AWS is invested deeply in, both in our products and our open source contributions. So the new SageMaker HyperPod clusters were really tackling these questions around fault tolerance and resilience at scale. Another thing you have to get right is training these models requires access to data. And a lot of AWS customers are training using data that's on S3. And so the Amazon S3 team has been doing a lot of work to optimize the performance of S3 for training workloads in particular. And so last year they released a new Amazon S3 connector for PyTorch, and we're actively working with the PyTorch community to understand what architectures are needed for large-scale data loading in these problems. And so there's both everything from low-level infrastructure optimization on the S3 side, all the way up through open source contributions to PyTorch. And it really is that. I think the takeaway here is the holistic perspective that you need when you start to do this stuff at scale.
Okay, great. Thanks, Brian. This question is from uTorque. I'm very glad to see someone from AMD. I saw that the last ROCm 6.1.3 update, there wasn't a possibility to use WSL for it, as well as an integration for PyTorch. Will it keep going in that direction?
Yeah. So probably this isn't the forum for me to get into specifics of point releases for ROCm, but generally I would say that our philosophy is to, as I alluded to earlier, continue expanding the footprint of PyTorch into AMD products. So things like the Windows subsystem for Linux very much is part of our overall vision of having AMD hardware available not only for users that have very demanding workloads that require high capacity of GPUs, either on-prem or through the cloud, but also researchers or hobbyists who may not have access to that scale of hardware, but also would benefit from having some degree of acceleration.
Excellent, excellent. So we got one more here. Sumit, how did the Dynet and Chainer influence PyTorch?
Oh yeah, Dynet and Chainer. Dynet less so, but Chainer was pretty central to PyTorch. PyTorch's influence. With Zeming Lin, who was one of the co-authors of PyTorch, and James Bradbury, another co-author of PyTorch. They both were heavily Chainer users and were part of the Chainer community, and they strongly advocated for the whole subclassing abstraction. And Chainer, we actually engaged with the Chainer team while building PyTorch. I went to Japan and visited them. And I would say like PyTorch's first iteration was heavily inspired by Chainer. And ironically, there's like a symbiotic relationship here because PyTorch, you think of it as like PyTorch took Chainer's front-end model and then maybe improved upon it, because in Chainer 2.0, you actually see some of the PyTorch improvements land back into Chainer. Dynet was largely a parallel effort that we only started noticing after PyTorch was published. But it's a very similar effort. It does take a slightly different approach of like lazy compiling that we considered but did not go through. I wouldn't say Dynet is an inspiration, but or an influence, but it was definitely something we deeply respected, and we actually engaged with the Dynet team at that time to see what things we could incorporate in.
Great, great. Okay, well, I think that brings us to time. I do want to thank all of our speakers today for taking questions, and obviously have played in the development of PyTorch. I'd also like to thank our audience members, many of which are also do play an integral role as contributors as well as users of PyTorch. So thank you very much, everyone. And you can find the documentary on YouTube after this event. And again, please feel free to share with your colleagues and friends. And thank you for attending today.